In this lab, I've enabled OSPF on all interfaces between R1, 2, 4, and 5. As a result, I've created multiple paths between certain destinations. For example, from R4 perspective to reach 10140, now it has 3 paths, directly via R5, or through R1 and R5, or through R2 and R5. How does OSPF handle this multipath selection here? It's pretty straightforward. OSPF uses the formula in which we have something called auto cost reference bandwidth, which by default is 10 to the power of 8. That equates to 100 megabits per second link. It is divided by the bandwidth of the interface that is found in this command, the show interface E00, for example. The bandwidth of the interface here is 10 megabits per second. 10,000 kilobits per second, that's 10 megabits per second. So in this lab, I don't have to change autocost reference bandwidth because all my links highest speed is 10 megabits per second. But if I were to use on the production system, I would have to change autocost reference bandwidth to match higher speed, like 1 gig, 10 gig, or maybe 100 gig. This is done via command here. So let's just scooch this over a little bit here. And here I would say router OSPF1 and command is autocost reference bandwidth, and this is where I specify parameter that matches the highest speed of the link here. Now I'm not going to do that because my lab is all 10 gig links, so the cost of each link is 10 gig. In fact, we can actually check that. So when R5 is advertising this 10.1.4 subnet, let's go to R5 real quick and do show IP OSPF database. And I want to see the LSA type 1 link state LSAs, which every router advertises, and what is the metric, what is the cost of that link being advertised to its neighbors from R5. So router LSA is LSA type 1, advertised by 5555. And I'm going to see that the 10.1.4.0 link is advertised with the cost of metric 10. 100 megabits per second divided by 10 is just 10, right? Now, obviously, R4 needs to add its own cost towards the R5. This is one link here, and 2 links here, and 2 links here. So what is the cost of the link, let's say E0 045? Well, I can, again, the same do, show IP OSPF database, show me the LSA type 1, router LSA, advertised by 4. And I'm gonna just scroll back up a little bit. There it is. This is also, so I'm advertising this cost of link as 10 because 10 to the power of 8 divided by the bandwidth of the interface, the cost is going to be 10. So the total cost here, I can now tell with absolute certainty, it's 10, 10, that's going to be 20. If I were to choose this path, it would be 10, 20, 30, and the same thing here, 10, 20, 30. So 20 is the lowest cost. The next hop address should be 10.1.45.5. Let's see that happen in the routing table. So what we're going to do, show IP route OSPF, and then the subnet 10.1.40, the cost is 20. The best one is via R5. Now, if let's say for the argument's sake, this link is a modem over the internet, I don't want to choose this one. I want to choose those 2 instead. But since this is the Ethernet, it thinks that it is 10 megabits per second, but in reality might not be 10 megabits per second. So how would I change that? There are 2 ways of doing that. One, I can change the bandwidth of the interface here on R4 towards R5, and the same on R5 towards R4. If I increase, let's say, decrease the bandwidth here artificially on the per interface basis, let's do that, T0045, and I'll do the same thing on here, conf T interface E0045. I can change that parameter on the interface, include bandwidth, to something that is lower speed. So I could say, for example, bandwidth, and the command takes arguments, number, bandwidth in kilobits per second. Currently we have 10,000. What if I make it, let's say, 100 kilobits per second? So 100 kilobits per second. If I did that, and I did the same command on the other link, do show interface E0045 include bandwidth. Now the bandwidth changed to 100 kilobits per second. So obviously the cost of the link, the metric calculated by OSPF auto cost divided by that bandwidth should be higher. Do show IP OSPF database router, that's LSA type 1, advertised by 4. Let's scroll back up and see that link now. The cost is 1000. If I change that costs auto bandwidth, let's say to maybe 1000, if I did the same thing, the cost of metric would be now 100, and so on and so forth. So obviously I should have exact same parameter here. So I use 1000 here, I'll use 1000 here as well. And now, since the cost of that link is higher, cost us more to get there, these two paths should do equal cost load balancing. And let's see that happen. If I do show IP route OSPF, and now I see the subnet available via cost of 30 via R1 and R2. So equal cost load balancing is happening. One session goes across this link and the other session will go across that link. So do show IP route 10140. We can see that traffic share count 1, traffic share count 1, that's equal cost load balancing. And we can see the next packet will be sent to this one. If we send the packet, maybe another session, it will show asterisk on this one, and that's the equal cost load balancing between them. Another way of doing that, so I can remove that command, in OSPF, we can artificially change the cost on that interface. Instead of doing that, so now we're going back to what we had, just one gateway through R5. What I can do is IP OSPF cost, let's say I'll make this cost of 30. If I make this cost of 30, IP OSPF cost of 30, that is now the manual cost assigned to the interface. Do show run interface E0045. Now the cost is equals 30. So 30 plus 10 is 40. It's definitely worse than across 10, 10, and 10, which is 30. So if I ask my router, how would you go back? How would you send the packets to 10140? Again, I get this equal cost load balancing through R1 and R2. And that's the way we can influence the cost selection in OSPF.